Hey team, I'm Maddie. Welcome to ScienceSideUp, and today we're going to talk about how alpha radiation affects living tissue. And really specifically, why you should definitely not lick the science if it's emitting alpha radiation. Okay guys, if you are new to this channel, welcome. Please hit that subscribe button so you can see whenever I get new videos out. Go ahead and give this a like, that really helps me out, and you guys are amazing. So today we're going to break down this idea of alpha radiation into three different parts. First, we're going to talk about what alpha radiation is. Then we're going to talk about how it affects living tissue, such as you and me. And then we're going to talk about why you definitely shouldn't lick it. So let's get started. All right, point one, what is alpha radiation? So if you watched my video on gamma radiation, which is why Bruce Banner would have just died, then you know that radiation is just like particles transporting energy. And there's three main types, alpha, beta, and gamma. And you might be wondering why we call them this. And that's because radiation was discovered in the early 1900s, and so they knew that they were getting radiation, right? So they knew they were getting this like energy being transported or transmitted through empty space. And that was really confusing to them, and they didn't know what it was, and they knew they were getting like different types, but at the time they didn't know what that was. So because they didn't know what it was, they just went with like the first few letters of the Greek alphabet, alpha, beta, gamma. For shorthand, alpha kind of looks like a Jesus fish, right? This is beta, and that's a gamma symbol. So I might draw, we're not going to deal with beta today, but I might draw alpha as that symbol instead of writing out the word alpha to save time. So that doesn't answer the question. What is alpha radiation? So alpha radiation is energy that's being transported by alpha particles. So we've got alpha particles that are just like running through the air, and they've got kinetic energy, and they've got charge, and they like wreak havoc and do stuff. So an alpha particle is the nucleus of a helium atom. So an alpha particle looks like this. So we'll use green for protons. They've got a positive charge. And we'll use orange for a neutron that has no charge. And so you just have these two protons and two neutrons that are bound together, and they're like running around doing their thing. So this is an alpha particle. Now really specifically, an alpha particle, as opposed to like a normal helium atom, an alpha particle doesn't have any orbiting electrons. Normally, helium would have two orbiting electrons, but an alpha particle doesn't. So it has a charge of +2. We'll use the color for protons, right? So it has this +2 charge, and that's going to be important later. So how do we get an alpha particle? Because we need an alpha particle to get alpha radiation. So what we have is some parent nucleus. We'll just draw a big orange circle for that. And that's going to be our alpha emitter. Alpha emitter. Some examples of alpha emitters are like radium is an alpha emitter, so is uranium, so is polonium. And these things undergo what's called alpha decay, right? So it radioactively decays and it produces the daughter nucleus. So you get another atom here that's about, or precisely, 2 protons and 2 neutrons smaller than the parent. So you get your alpha emitter, plus you're going to get your alpha particle. I'll just draw the letter alpha. And then you'll also get a photon, because we always get photons that come out of these things. Cool. So, fun fact, when radium alpha decays, the photon that it emits is actually green. So it's emitting a photon in the wavelength of visible light, and it's always green. So if you're ever wondering why, like, The Simpsons or any cartoon or any picture portrayal of radiation, right? Why it's always showed as glowing green, it's actually because one of the first radioactive things that scientists work with, specifically Marie Curie did a lot of this work. She worked a lot with radium. She actually discovered radium as an element. And so her whole workshop glowed green. And that's because this photon it was emitting was in this decay chain, right, in this decay process. This photon for radium is always green visible light. Now, what's important about that is that visible light is non-ionizing radiation. I'm going to refer you back to why Bruce Banner would have died. So this photon, if this is radium, is actually pretty low energy, and it's not capable of harming you or I or your puppy. Okay, so to answer the question, what is alpha radiation? Alpha radiation is an alpha particle that's being emitted, right, and flying through the air, taking energy with it. So now let's come to point number 2. How does an alpha particle or alpha radiation affect living tissue? So it can really do 2 things as my hand gets caught up in my microphone cable. So an alpha particle can really do 2 things. So if we're talking about things that are the size of atoms, atomic sized, having an alpha particle running around, like, this thing is ginormous to just be rushing off on its own. So it's moving, right? And if it interacts with, like, say, a cell of yours or something, it can straight up just come in and go Hulk smash and, like, kill the cell. So it can deposit all of its kinetic energy all at once if it runs into something and just destroy a cell. And that's literally just, like, think about it if I was, like, throwing a baseball at your face right now, right? That would just smack you in the head and do quite a bit of damage, right? So an alpha particle can do that. But one of the other things it can do is, this is where that +2 comes in. So this has a positive charge of +2. So this guy is going by other atoms in your body, right, or in some living tissue, and they have orbiting electrons, right? Well, that +2, as this travels by, it's gonna try to pull those electrons towards it. So it can create ions, right? So if you guys remember in chemistry, the goal in chemistry of an atom, its goal is to be, like, neutrally charged. It wants to be as stable as humanly possible. It doesn't want to have either too many or too few electrons, right? And if it has that, then it's going to go off and create a chemical bond of some sort to get that electron, right? So as this guy, this alpha particle, is flying by, ripping off electrons, smashing through stuff, then that's going to upset the very delicate chemical balance that's in your cells. So basically what you end up with is chemical reactions happening where you shouldn't have chemical reactions happening. And this can cause cell death. Another thing that it can do is if this alpha particle comes through, or it creates these ion pairs, an ion pair is the free electron and then the atom that it's left over. So if you create those ion pairs, as a cell is dividing, that can be really dangerous, because as a cell is dividing, your DNA is exposed, right? So it can cause, again, chemistry to happen where chemistry isn't supposed to happen, and end up with a genetic mutation in that cell, right? And then that cell replicates and produces more cells with this mutation. So that's one of the ways that like radiation can cause cancer, right? Because cancer is unregulated cell growth that's caused through a series of genetic mutations. Now that I've got you guys good and terrified, let's move on to point number 3. All right, point number 3, do not lick the science. So the good news for us is that alpha particles, like we said earlier, they are ginormous when we're talking about atomic scale things flying through the air. This means that alpha particles are fat and slow. So when an alpha particle comes in and hits a person, right, our epidermis, just the layer of dead skin, is completely enough to protect us. So we, in fact, as living creatures, have a built-in alpha shield. And so alpha radiation coming at us from outside of our bodies, interacting with like our skin, it's gonna deal 0 damage. Sorry, that was an accidental D&D reference. That's gonna do no damage because it's not interacting with living tissue and it's too fat and slow to make it through our skin. So how does alpha radiation actually affect people? Well, the problem is if you breathe in or swallow an alpha emitter. So if this, let's pretend this chalk was radium. Nailed it. If this chalk was a hunk of radium, I could hold it in the air all day long and I am perfectly safe. But if I were to breathe in the chalk dust, or if I were to take a big bite out of it, then that alpha emitter gets inside my body and I don't have my alpha shield, right? I don't have my layer of dead skin protecting me. So then I have these alpha particles interacting directly with living tissue, and that's when they're really, really, really dangerous. An example of that is going to be the radium girls. Who are the radium girls, you ask? That's a great question. So we already talked earlier about how radium would glow green. And so people thought it would be they put radium in everything before they knew how dangerous it was. And one of the things they put it in was paint to make it glow in the dark. And this paint was often used to make the numbers on a clock glow in the dark, right? And there were factories where women were hired to paint on those little numbers, right? Well, and how do you get your paintbrush just right so that you can paint those delicate numbers? You lick it. You lick the tip of your paintbrush, you put it in your radium-infused paint, and you paint the numbers, and you do that over and over and over. And the radium girls suffered horrendously. They had terrible injuries. Some even like their whole jaws like fell off. And I'm not gonna post any pictures because they're really gruesome, but the radium girls are actually a really interesting read because they were also some of the first people who successfully sued their employer for like knowingly putting them in danger in the workplace and not informing them. And so the Radium Girls 1 taught us a lot about why we shouldn't lick the science, but it also set really important legal precedents for like responsibilities towards your employees. But anyway, that is all I've got for you guys today. Thanks so much for hanging in here till the end, and I will see you all soon. Have a good day.